Welcome students. Today in this session, basically we are going to solve all the questions that has been asked in the mock test 2. Okay. So as you can see, it is of 30 marks. The time given was 60 minutes and there was negative marking at the rate of 0.25 for each wrong answer. Okay. The topic was basic concepts. So starting with the first question, what was asked? Resistance of a wire depends on, what do you know? You know that resistance of wire R is basically proportional to L by A. Okay. Where L is the length of the conductor and A is the cross section area of the conductor. Okay. That means A is correct, C is correct. Also what we know, R is equal to rho L by A, where rho is the resistivity of the material of the wire. That means it also depends on the material. And what we know, the resistance of wire depends upon the ambient temperature. Means generally for conductors, with the increase in temperature, resistance increases, and with the decrease in temperature, resistance also decreases. So the resistance also depends upon the temperature, which is basically given by RT is equal to R0 into 1 plus alpha T, where T is the change in temperature from 0 degree centigrade and alpha is the temperature coefficient of resistance. Okay. So the resistance also depends upon the temperature. That means this is also true. So what will be the actual answer? As A, B, C all are correct. So here the answer will be all of the above. Okay. Now we must go to the question number 2. When n resistances each of value R are connected in parallel, then resultant resistance is X. Okay. That means if each resistance has a value of R, the equivalent resistance here X will be small r by n. Okay. Next, when these n resistances are connected in series, what will be the total resistance? Okay. That means each resistance has a value of nx. So now these n number resistances of R value are connected in series. That means the new equivalent resistance when these resistances are connected in series will be n into small r, that will be equal to n into nx. That means this will be n square x. Okay. So what will be the option here? The answer, option D here will be the correct answer. Okay. Next, for question number 3. Ohm's law cannot be applied to which circuit? Ohm's law. We generally know basically Ohm's law generally applicable to most of the circuits, but there are some circuits where it is not applicable. What are the options here? Unilateral. First you have to know what is unilateral. Unilateral circuit is such kind of circuit where with the change in the direction of current, the characteristics of the circuit changes. Okay. Means if the circuit is having a diode, then with the change in the direction of current, in one scenario it may be carrying current and in other scenario it may not be carrying current. Okay. And what is bilateral circuit? It is such kind of circuit where with the change in the direction of the current, characteristics of the circuit doesn't change. Okay. And it says rectifier. Rectifier means it is having PN junction devices where with the change in the direction of voltage, when the direction of current basically changes, the characteristics of the circuit changes. In this case, what do we know? The Ohm's law is not applicable for unilateral circuits where basically PN junction devices like diodes are used. So unilateral circuit will not support Ohm's law. Similarly, a rectifier is basically having PN junction devices. So the option C is also correct. Means these two options. So basically, if it would have been given A and C as our answer, that would have been our answer. So here you can directly write as for unilateral circuit, the Ohm's law is not applicable. Okay. So what is the next question? The next question is the mass of proton is roughly how many times the mass of an electron? For that you must know what is the mass of an electron and what is the mass of a proton. Okay. So mass of an electron is 9.1 into 10 to the power minus 31 kg. and mass of proton is 1.67 into 10 to the power minus 27 kg. So just divide MP by ME. Okay, that will give you how many times the mass of an electron is to that of the proton. Okay, so just calculate MP by ME. You will get it to be as approximately 1840. Okay, so here the answer will be option C. Now next, what is given? It is given the charge of an electron is known to be 1.6 into 10 to the power minus 19 coulomb. It is a very important data. You must remember this, that the charge of an electron is 1.6 into 10 to the power minus 19 coulomb. In a circuit, the current flowing is 1 ampere. Okay. Then how many electrons will be flowing through the circuit in a second? Now what you know? The current I is equal to Q by time t. That means charge flowing per unit time is basically your current or rate of flow of charge. Okay. So the charge is here given of an electron and you have to count what is the number of electron. Okay. Let us say the Q is equal to N into number of electron, means this number of electron is basically flowing, and time is given as a second, so this is 1, and also I use 1 ampere. So 1 is equal to N into 1.6 into 10 to the power minus 19. So after calculation you will get that N is equal to 0.625 into 10 to the power 19. So for this circuit the number of electron flowing is basically 0.625 into 10 to the power 9. So answer here will be C. Okay. Next question. Two bulbs marked 200 watt 250 volts, 100 watt 250 volts are joined in series to 250 volt supply. Power consumed in the circuit. Okay. So for this, what you have to do? You have to first calculate the resistance of bulb 1 and the resistance of bulb 2. The situation is like this. This is the situation. Okay. So you have to calculate the resistance of bulb 1 and the resistance of bulb 2. And the voltage applied given is 250 volts. So R1 is equal to V square by P1. That means this will be equal to 250 into 250 divided by 200. This will give you 625 by 2. That means 312.5 ohm. And what we will get as R2? R2 similarly will be 250 into 250 divided by 100. So you will get this as 625 ohm. Okay. So the total resistance here will be Req R1 plus R2. That will give you as 937.5 ohm. Okay. So what is the power consumed here? You know, power consumed P is equal to V square by Req. Here the applied voltage is again 250 volts. So 250 into 250 divided by 937.5. Okay. This value to be as 66.666. Okay. That means approximately equal to 66.67. That you can take it to the option number B, that is 67. Okay. So here the answer will be 67 watt. What question number 7 says ampere second could be the unit of. Okay. So what is ampere? Ampere is equal to coulomb per second. Okay. So ampere second is equal to coulomb. Okay. And coulomb is a unit of charge. So option number D here is the correct answer. Okay. Next, which of the following is not the same as watt? All of you know that joule per second is what? Means energy per second is basically what? Okay. The option B is amperes per volt. Okay. Let us check other options. Ampere volts means it is resembling P is equal to VI, that is the unit of power or watt. And also we know P is equal to I square R, that is also gives you power in watts. Okay, so this is also true. That means this option, the option B, is the correct answer here because it is not representing the power or the power in watts. Now question number 9. 1 kilowatt hour of electrical energy is same as, means you have to calculate which one is correct. 1 kilowatt hour is equal to 1000 watt hour, and we know 1 hour is equal to 3600 seconds. So this is your watt seconds, and you know that watt second or watt second is basically joule. That means this is equal to 36 into 10 to the power 5 joule. Okay, so definitely the option C here is the correct answer. An electric current of 5 ampere is same as, you know that ampere can also be written as coulomb per second. Definitely this ampere can be written as coulomb per second. So this is same as this. So option C here is the correct answer. Okay. In question number 11, what has been asked? An electron of mass m kg and having a charge of E coulombs travels from rest through a potential difference of V volts. Its kinetic energy. Definitely if the speed or the velocity was known, then it would have been half mv square as an expression. But from the given data, as you know, when E charge or that electron having charge of E coulombs is basically going through a potential difference of V volts, the energy associated is basically given as electron volts, and the electron volts here is E into V electron volts. So definitely here the answer will be EV joules, which is the energy here. Okay, so option A here is the correct answer. Okay, the value of the following is given by 100 kiloampere into microampere. It seems that the question is basically wrong. Okay, because this expression is not correct. So skip this question. So taking the next question, a circuit contains two unequal resistances in parallel. Okay, option A, current is same in both. Large current flows in large resistor. Potential difference across each is same. Smaller resistance has smaller conductance. Okay, so definitely the current is not same because two resistances are having different values. So this is wrong. Large current flows in large resistor. This is also wrong because when two resistances are in parallel, the resistance having larger value will carry smaller current. So this is wrong. And smaller resistance has smaller conductance. This is also wrong because we know that conductance G is 1 by R. So smaller resistance will have higher conductance. So definitely the option C is correct. Still we read. Potential difference across each is same. Definitely because for parallel connection the voltage remains the same. So option number C is correct. Next, conductance is expressed in terms of, we know G is 1 by R. That means the unit is 1 by ohm, that is mho. Okay, or another new unit is Siemens. So here in option mho is given in D. So the conductance is expressed in terms of mho. Option number D is correct. Which of the following could be the value of resistivity of copper? So it is a database question and you have to know this value. The value of rho, that is the resistivity for copper, is 1.7 into 10 to the power minus 6 ohm centimeter. Okay, so option B is correct. Next, question number 16. A copper of length L, diameter D has potential difference V applied at its two ends. The drift velocity is Vd. Okay. If the diameter of wire is made d by 3, then what will be the drift velocity? Okay. Now you must know that the drift velocity of electrons in a wire doesn't depend on the diameter of the conductor. So when it is changed from d to d by 3, it will not have any type of effects on the drift velocity. So definitely when the diameter of the wire is made d by 3, the drift velocity will be same as that of the previous, that is Vd. So here the option D is your correct answer. Okay. Next, two resistances R1 and R2 give combined resistance of 4.5 ohms when in series. So definitely R1 plus R2 is equal to 4.5 and 1 ohm when in parallel. As we know, R1 R2 by R1 plus R2 is the equivalent resistance of two resistances connected in parallel. So this will be equal to 1. That means R1 plus R2 is equal to R1 R2. Now R1 plus R2 is equal to 4.5. So R1 R2 is equal to 4.5. Now just put the value of R2 or R1 from here to this. What we get? R1 plus 4.5 by R1 is equal to 4.5, which will give you R1 square minus 4.5 R1 plus 4.5 is equal to 0. Okay. So now solving this quadratic equation, what we will get? We will get R1 is equal to 4.5 plus minus root over of minus 4.5 square minus 4 into 1 into 4.5 divided by 2. Okay. So from this, what you will get? You will get this is equal to 3.5 or 1. So if R1 is equal to 3.5, then definitely from R1 plus R2 equal to 4.5, what we get? R2 equal to 1. All these are in ohms. And if R1 is equal to 1 ohm, then from R1 plus R2 is equal to 4.5, we get R2 is equal to 1.5 ohm. Okay. So the option number C here is the correct answer. Next, question number 18. We have three resistances of values 2 ohm, 3 ohm and 6 ohm. Which of the following combination will give an effective resistance of 4 ohm? Okay. All the three resistances are in parallel? Definitely not, because in that case Req would have been 1 by 1 by 2 plus 1 by 3 plus 1 by 6. This will not give you 4 ohm. 2 ohm resistance in series with parallel combination of 3 and 6 ohm. What will be the resistance here? 2 plus 3 into 6 by 3 plus 6. This is equal to 2 plus 18 by 9, which gives you 4. So this is the answer. Okay. We don't have to see other options. Now question number 19. Three equal resistors connected in series across a source of EMF together dissipate 10 watts of power. Three equal resistors. Let the resistor having resistance of R ohm. Okay. So three resistors in series. So this will give you 3R. And let the power P, as we know, is equal to V square by R. So V square by 3R. This is here 10 watts. Okay. Now what would be the power dissipated in the same resistor when they are connected in parallel across the same source of EMF? If these resistors are connected in parallel, then Req would have been R by 3. So in that case, P dash will be V square by Req. This will be equal to 3 V square by R. So definitely this will be equal to 3P, and P given here to be as 10 watts. So 3 into 10 will give you 30 watts. Okay. So option B here is the correct answer. Now this is a very well known question. So current is going from this point to this point. All the resistances are given to be having a value of R. You have to find the effective resistance between P and Q. Now if you say that I current is entering here, so definitely as all the resistances are of same value, so this resistance and this will be having a current of I by 3. Okay. Again here this resistance and this resistance will be having a current of value I by 6. Means again it is divided into two segments. Here it has been divided into three segments. Okay. Now here again what is happening? This is again divided like this, but here also it is coming to be as 1 by I by 3. So in such a manner it will get divided and finally we will get here I. Okay. So if we take the equivalent circuit here, how this will look like? This will look like this. Similarly here this will be like this. Okay. So here will be I, again here will be I. This point let us take as P and this point as Q. So here the current will be I by 6. Okay. All the branches are having I by 6. So this will give you R by 3. This will give you R by 6 and again this will give you R by 3. So total resistance Req basically will be R by 3 plus R by 6 plus R by 3. That means here this will be 6, here will be 2R, here will be R and this will be 2R. So the equivalent resistance will be 5 by 6R. Okay. So this will be B. Next, what is given? When P is equal to power, V is equal to voltage, I is equal to current, R is equal to resistance and G is equal to conductance, which of the following relation is correct? Okay. The first option is V is equal to root over PR. Means V square is equal to PR. That means V square by R is equal to P. Okay. So definitely we know that power in a circuit is voltage square divided by the resistance. So this will be the answer. We don't have to check other options. Now what is the breakdown strength of atmospheric air? It is a database question. You have to remember the breakdown strength of air, atmospheric air. It is basically 30 kV per centimeter. Okay. Breakdown strength of air is 30 kV per centimeter. So C here is the correct option. Now question number 23. Two 200 ohm 2 watt resistances are connected in parallel. Their combined resistance value and wattage rating are. So basically the resistances are connected like this. This is of 2000 ohm. This is of 2000 ohm. So definitely Req will be 2000 divided by 2, that is 1000 ohm. Okay. Now both the resistances are having a wattage of 2 watt. So basically the power rating P is equal to V square by R. So the voltage rating V is equal to root over PR, which here is P is equal to 2 and R is equal to 2000. Okay. So this will be equal to 20 root 10. Now this is the voltage rating. Now this voltage is basically applied here. Now the power rating of the whole or the equivalent system will be this V square by Req. So V square is 20 into 20 into 10 and Req is 1000. So after cancelling these zeros we get 4 watt. So the option C, not C, the option B is the correct answer here. Okay. Next question. The equivalent resistance between terminals X and Y of the network shown is, as you can see here, this is a bridge circuit. We can redraw it like this. This is R, the unknown resistance here. This is 5, this is 15, this is 10 and this is 30. Now if we take this as P, this is Q, this is R and this is S. What do we know? For a balanced bridge circuit, P by Q is equal to R by S. Here P is 5 and Q is 10, R is 15 and S is 30. So this is basically giving 1 by 2 and this is also giving 1 by 2. So they are basically same. So the relation holds. That means there will be no current through this branch. No current. So we can take it to be as open. So the equivalent circuit becomes like this. This is 5, this is 15, this is 10 and this is 30. So finally, what will be the equivalent resistance? 20 ohm in parallel with 40, which is nothing but 20 into 40 divided by 20 plus 40. This will give you 800 divided by 60. So now dividing both the numerator and denominator by 2, we get 40 by 3. So the equivalent resistance here is 40 by 3 ohm. So option C is the correct answer. In question 25, it has been asked that a stove element draws 15 ampere when connected to 230 volt line. How long it will take for that element to consume 1 unit of energy? Okay, 1 unit of energy means 1 kilowatt hour. Okay, now the current is 15 ampere and the supplied voltage is 230 volts. So we know power is also given by V square by R or VI. So here the energy given will be 1 kilowatt hour is equal to P into T, that is the time, and this time is required to be found out. Okay, so 1 kilowatt hour is nothing but 1000 into 3600 joules, as 1 hour means 3600 seconds. So now put here VIT. Now putting all the values, 230 into 15 into T, what we get? T is equal to 1000 into 3600 divided by 230 into 15. This will give you 1043.47 seconds, which is equal to 0.289 hours, which is approximately equal to 0.29. So here the option D will be our correct answer. Okay, first of all, this 2 microfarad is in parallel with 1 microfarad, so this will be added. So what we get? 3 microfarad. This is in series with 2 microfarad. So 3 into 2 divided by 3 plus 2, that is 6 by 5 microfarad. Again, this combination in parallel with 1. So 6 by 5 plus 1 will give you 11 by 5. Now this combination is in series with this 2 microfarad. So 11 by 5 into 2 by 11 by 5 plus 2. This will give you 21 and this will be 22. So 22 by 21. Again, this will be in parallel with 1 microfarad. So add 1. What you will get? You will get 43 by 21 microfarad. So now what is 43 by 21? This is 2.047. 2.047 microfarad, which is approximately equal to 2.05 microfarad. Okay. So option number D here will be the correct answer. Next, if the number of turns of a coil is increased, its inductance. What do you know? The inductance L of a coil is basically given by mu 0 into mu R into N square into A by L, where mu 0 is the permeability of free space, mu R is the relative permeability of any medium, N is the number of turns of the coil, and A is the area of cross section of the solenoid, and L is the length of the solenoid. Okay, so this is the formula for finding the inductance of a solenoid. Now if N is the turns, then with increase in the number of turns, L will also increase. So if the number of turns of a coil is increased, its inductance will also be increased. So option C is the correct answer. In question number 28, it's given a bar of iron of 1 centimeter square in cross section has 10 to the power minus 4 Weber of magnetic flux. If mu r is 2000, what is the magnetic field intensity in the bar? The magnetic field intensity and flux density is related by B is equal to mu 0 into mu r into H. Now what is B? B is equal to phi by A, where phi is the flux in Weber and A is the area of cross section, definitely in meter square. So it is 10 to the power minus 4 and 1 centimeter square means 10 to the power minus 4 meter square. So by 10 to the power minus 4, that means B is 1 Weber per meter square. So this is 1 and you have calculated this H, that is the magnetic field intensity. Now what do we know? Mu r is 2000 and mu 0 is 4 pi into 10 to the power minus 7 Henry per meter. Now put the value of mu r, that is 2000, into H. So H will be equal to 1 by 8 pi into 10 to the power minus 4. So this will give you 1 divided by 8 divided by 3.14 into 10 to the power 4. That means 398, approximately 398 ampere turn per meter. Okay, so here option B is the correct answer. Next, a resistor is connected across a 50 volt source. The current in the resistor, if the color code is red, orange, silver, that means red R will give you the number value 2, orange will give you the number value 3, and again orange means the multiplier here is 10 to the power 3, and the silver, that is the tolerance here is plus minus 10% as it is silver. So the resistance of the resistor is 23 kilo ohm plus minus 10%. Okay, so definitely the current will be V by R. Just directly take the actual value, ignoring the tolerance, you will get 50 by 23 into 10 to the power minus 3. Okay, now what is 50 by 23? This is 2.1739. So this will be 2.17 milliampere, that is approximately equal to 2.2 milliampere. Okay, so here answer is option number C. And now the final question, that is the question number 30. Tesla is the unit of which quantity is having Tesla as its unit? As of now, we all know that Tesla is basically nothing but Weber per meter square. That is basically the flux density. Okay, flux density, definitely the magnetic flux density is written as Weber per meter square. That is also same as Tesla. Okay, so it is basically the unit of magnetic flux density. So option D here is the correct answer. So this is all for now. I will be coming up with a new mock test as well as the solution in detail. Hope all of you have learned and understood that how we have got the solutions here. And this question paper is totally designed for SSC JE as well as assistant engineer examinations of different public service commissions of different states. So I think all the students who have come here will definitely get benefited. Thank you. Thanks for watching.